Hi, I'm Will. I'm going to take you through the hardware. Over here we've got the hardware for the SunSmart project. We've got the particle photon is going to be the backbone of it. Going to handle all the communications and actually aggregating the readings. Next we've got the UV sensor. That's an Adafruit VEML 6070. And then we've got the Adafruit Ultimate GPS breakout to match geospatial data to the UV aggregation. At the moment, just for demonstration, we have it recording data every 10 seconds and it's aggregating after 3 readings. So after it's recorded the 3 readings and averaged them, you can see the average was 125, it sends to the server. Last reading sent ended in 9044. And then over here on the server side, we've got 9044 over there, same values. All right, so in testing out the UV sensor and trying to relate the output of it to some sort of usable value, we noticed that in direct sunlight, it was reading just over 1,000. And so we figured if over the course of your 10-minute aggregated readings, if the results is over 1,000, then you've been in the sun too long and we'll turn on an alert. So I'm going to use my phone to simulate that. Set the flashlight right on top. First reading was 115. And the aggregate for these 3 readings is 2508, which triggers the alert, flashing LED. And that'll stay on until the next aggregated reading is below. And after receiving a reading of aggregated to 72, the light shuts off. Okay, and that we were using 3 minutes or 3 readings as an example, but in practice we're going to leave it set to take 60 readings before it aggregates, 10 seconds apart, so 10 minutes. So one advantage of using a queue, this data queue object is a vector of data point objects, so we're able to push to the back of it when we have a new reading to in queue. And then if the response to the publish, where is it? If the response to the publish is good, then we remove the one that was sent up, and if it's not, we just leave it there, ready for checking again. And those will persist for 24 hours. If after we queue, we check to see if there's any old records, and if there are, we check their timestamp. If it's older than 24 hours, we'll just get rid of it. We'll just remove that from the front end. And we're able to check that on the front end and leave the back end for adding. It's the advantage of first in, first out.
Hi, I'm Walker, and I'm going to be taking you through the back end of our project. So going into our the furthest out and kind of bringing you in our models, this is where we're going to set up all of our Mongo database structures. So we have one for devices, and this is for like Will's particle device has an ID, an API key, and so on and so forth. Infos, if you're taking in here, there's a schema for, so we have a device ID, a time, a UV, a latitude, longitude, and this is all information coming from the particle. And then in users, this is the user for logging in, registering, all that good stuff. Then we have routes for all 3 of those files. So in devices, we have our put request to update our device. We have our get, we have our post for registering a device to a user, and then we also have a get UV status for our exposure page, so we can pull the UV exposure for our infos. We have our post to SunSmart, and this is our RESTful API that Will is sending to. Cool. And then in users, this is where we're taking in our post request to register a user, our get request for the status of the user, our update user to update user information, and that's a put request. And then in so our app.js file kind of like sets up our whole program. So it brings in the JS files from routes and brings them into here. And then in our db.js, this is where we're setting up our Mongo database, and we could say that we're connecting to localhost UV database, and this is where all of our information is getting stored. In public, we have our JavaScript files, we have our SunSmart CSS page file to format our HTML files and all of our HTML files for our website. And then we got, yeah, and that's about it. So in our server side, these are all the files that are located on our server that are working together. Our app file, our bin data, db.js models, node models, package.json, public routes and views. And then if we go back out of this one time, this is where our JWT key is located. So it's off of the server, it's not hard coded in. And our geocode API key is actually the API key to our weather app. So if we go back into there, we can go to our Mongo database. And then we can show our collections. And you can see that we have 3 collections: our devices, our infos, and our users. And to just take you into one of those, we can do db.users.find, and then you can see that there's people emails, their full name, and then their password hash, so we can't even access the password that they registered. So we set up our app.js to use Express, and then this is where we're also setting an app up for Express. So this is a AJAX call to our third-party API. This is grabbing the weather forecast for whatever zip code you input. Right now it's set up to pull in Tucson's. It's at Tucson zip code, and I hard-coded the API because I can't have a backup file. But on the server, the API is located in that external file. In each one of our JavaScript files, if you try to access that endpoint without successfully logging in first, whenever the DOM content is loaded, it will check local storage for your token, and if the token doesn't exist, then it will relocate you to the sign-in page where you have to sign in to get your token. For our SunSmart sign-in page, this is where you go to sign in, and if you don't have an account, then you would go to sign up down here at the bottom. Account registration, we can go ahead and type in will@gmail.com for our email. Will Carroll for our full name, our password. If the password is too short, so we can do like a short password and then try to register, and it will say the password is too short. So our password right now is set up to be 8 characters long. So I'm just gonna put 1, 2, 3, 4, 5, 6, 7, 8, so I don't have to remember a password. And then we won't get that too short. So it'll send us back to our sign-in page. Our account was now registered in the database. So now we'll be able to log in at gmail.com. And then let's say we enter in the wrong password, then obviously it will give us an error message for the wrong password. So now we can sign in with the right password, and up here it will give us the email, the user, the name of the user, and the last access. So we have forums to update our account, add devices, and update devices. And since Will doesn't have a device set up yet, we can go ahead and add a device, make a device ID, and then it will give you the API key for your device. And also we can say update device for Will, and we can type in another device and then say update. And then you can see on the bottom, you get a message that says refresh the page after update to update device list. So whenever you hit device update, it will make the put request and it will update the database, but it won't update the list until you refresh the page. So now once we refresh the page, we can see that the device ID was updated along with the API key. Going into forecast, it jumps into the first. So on default, the weather is in degrees and in military time. So this is our 3-day forecast for the Tucson of weather. And so this is our AJAX call to our third-party API for zip code 85742. And so we can type in another zip code that we are curious for the weather, and we can hit enter, and it will update our graph for this case Gracewood, and it will give us our 3-day forecast over that period of time. Going into health, safety tips for SunSmart. We got some nice colors going on here, and at the bottom we got our 3 links to different like safety websites. One's the American Cancer Association, American Academy of Dermatology, so we can click that. We can click that link, and it will relocate us to that web page. So we can go back to those, and then we can go to our sunscreen page, and then we can say what time that we applied sunscreen, what brand that we did, and then the SPF, so we can do 75. And we'll say that Bullfrog protects results, blocks 98% of the UV rays, and so we can change it to like 15 at 4, and Banana Boat, and it will say Banana Boat protects results, blocks 93% of the UV rays. So that's what that page does. And then to kind of show you more on the exposure page, we're going to go ahead and sign out and sign back into the account of Walker to show you, because this one is hooked up to Will's particle device. So this is Will's particle device ID along with his API key.
Don't steal it.
So we can go to exposures, and it will show us the aggregated UV ratings over a 10-minute period. That will show us all of our readings, our UV readings, and it will show us the aggregated UV for the full name. So this is full name, since the account uses Walker for both the email and the full name. This is actually the full name of the user. So Will is putting his camera light back on the UV sensor to get a high UV exposure, and so we can see on our database side we're getting a very high aggregated UV reading of 1471. And so whenever we go back to our server, we can see that it goes, and then we have a quick pop-up of the high UV reading. And so if we refresh the page again, we can say your UV reading has exceeded 1000, and it will show our UV readings that are, so this is the most recent, and this is the next one, and these all the rest that follow. So to demonstrate our token-based authentication, so if we don't sign in before we try to access an endpoint such as Forecast, then you can see it will try to access Forecast, but then it will jump you back to your sign-in page because you don't have they can't authenticate your token.
So now we're going to show that we can use this thing on a mobile device. Sign in as Walker. We're not responsible for how hard it is to type on touchpads, so we can't really fix that. And there we go. You can see all the information. It's all collapsible. Our menu looks good. Let's look at the forecast. There we go. Let's put in a different one. Go away, LastPass. Also weather for Tucson, but a different part of Tucson. Yeah.
We can go to exposure too.
Yeah. Show the aggravated UV.
Here's our 2 big spikes.
Yeah. So yeah.
This is ECE 413 with the group with Walker, Will, and Brittany, saying thank you for joining us for another exciting episode of On the Patio. Thank you. Bye.